A 20 Newton pomegranate is lifted at a constant velocity from the floor to a height of 1.50 meters. How much work is done on the object? So the object is lifted at a constant velocity, and there is also a weight of the object, which is 20.0 newtons. Since the object is lifted at a constant velocity, the net force is 0, which means that the applied force would also be 20.0 newtons. How much work is done on the object? So let's write the formula for work. So work is equal to the force applied and then the direction the object is moving. Sorry, the direction the object is moving, the change in displacement, which is equal to, work is equal to, the force is 20.0 newtons, and the displacement is 1.50 meters. The object is 20 times 1.5. The object is experiencing 30 newtons meters of work, which is 30 joules of work, because newtons times meters is joules, is the unit makes up the unit joules. Next question. Of 15 Newton potatoes move horizontally 3 meters across a level floor using a horizontal force of 6 newtons. How much work is done with the potato? So a potato that weighs 15 newtons, which means the force of gravity is 15 newtons. That means there's a normal force since it's on a surface. But it is moved 3 meters across a level floor using a horizontal force, so there's also an applied force horizontally. There is no mention of the force of friction, so I'm going to assume it's negligible and won't take it into consideration. But the direction is moving is 3 meters horizontally, so I don't need to talk about the force of gravity or the normal force. I just need to think of the direction the force is moving, which is horizontally. Now, it's moving 3 meters across, so that's the formula for work. The force times the change in displacement. We know that the force applied is 15.0 newtons, and the change in displacement is 3.00 meters. That should give us 45, geez, what is happening? 45 Newton meters, which is 45 joules. Now a 2.2 Newton pair is held up 2.2 meters above the floor for 10 seconds. How much work is done on the pair? So we know that the work is equal to force times the displacement. The pair is 2.2 newtons in weight, but the pair is not moving. It's just held above the floor. Since there's no displacement, the displacement is 0, so the work would also equal 0. A 10 kg pink grapefruit is accelerated horizontally from rest to a velocity of 11.0 meters per second in 5 seconds by a horizontal force. How much work is done on the pink grapefruit assuming no friction? So let's draw a diagram. This is not the shape of a grapefruit, but it's okay. So the grapefruit is 10 kgs. There is a force of gravity acting on the grapefruit. There is a normal force since it's on a surface. Oh my god. The grapefruit has no friction, and there is an applied force on the grapefruit causing it to move 11.0 meters per second in 5 seconds from rest. So there is an acceleration. We know that work is equal to force times the displacement. And since there's the acceleration and the mass will help us find the displacement. So let us find the acceleration. Force is equal to mass times acceleration. And acceleration is equal to change in velocity over time. Change in time, which is 11.0 meters per second over 5.0 seconds, which is 2.2 meters per second squared. Now we also need to find the displacement. So the displacement, we can use the displacement formula, which is VI times time plus 1 over 2a times t squared. Velocity instant is at rest, so this is 0. 1 over 2a squared is 0.5 times 2.2 meters per second squared times time, which is 5 seconds squared. So 0.5 times 2.2 times 5 squared, which is giving us 27.5 meters. And with that information, we can find the work. So work is equal to force times displacement. We know force is equal to mass times acceleration. So mass times acceleration times displacement. We'll just plug in the numbers. So 10 kgs times the acceleration, was 2.2 meters per second squared, times the displacement, which is 27.5 meters, which is 605 newtons meters, which is 605 joules. How many three significant figures? We're doing fine. So now this is at an angle. Interesting question. A 90 Newton box of papayas is pulled 10 meters along a leveled surface by a rope. If the rope makes an angle of 20 degrees with the surface and the force in the rope is 75 newtons, how much work is done on the box? So there's a force of gravity acting on this papaya, which is 20 newtons. It's on a surface, normal force. Now there is a force of 75 newtons that the rope is exerting on the box. And the box moves in the horizontal direction by 10 meters. Now, when we're looking at the work formula, which is force times the displacement, since the box is moving horizontally at 10 meters, that is the force, the horizontal component of the rope, the horizontal component of the force that the rope is exerting on the box is what we have to consider for the question. Since basically the force is parallel to the surface, which is in this direction. And since we know it makes 20 degrees with the surface, the force of the rope makes 20 degrees with the surface, we know that the force in the horizontal direction, force applied X, or force of tension X, is equal to 75.0 newtons cos 20 degrees. And we know it traveled 10 meters. So with this information, let's plug in what we have. 120 newtons cos 20 degrees times 10 meters. This should give us 5 cos 20. 704.7694 newtons meters. Significant figures, since there's 3 significant figures. There is one sig figure here, but since it's an angle and just a ratio, we don't count that as a count that in significant figures. This sig figs would give us 3, so there would be 705 joules. A 60 kg student runs at a constant velocity up a flight of stairs. If the height of the stairs is 3.2 meters, what is the work done against gravity? So, the flight of stairs is like this. It's 3.2 meters. The student is moving upwards. He's working against gravity. So against gravity is this way. Fg. And then he's going against gravity. So a 60 kg kid, so we know the mass of the kid, and we know the acceleration he is going against, which is 9.8 meters per second squared, and we know the distance he's traveling. So, and he's also runs up at a constant velocity, which means the F net is equal to, so the F net in this situation is equal to FA minus FG, and since the F net is equal to 0, FA would equal FG. But that's just a long way of saying FA is equal to FG. So the force and the direction is traveling 3 point displacement. So the force is equal to m times g. since FA is equal to FG, since it's going at a constant velocity, and the displacement is 3.2. Okay, 60 times 9.8 times 3.2 is 1881.6 newtons joules, and since there is 2 sig figs, we'll have to do 1.8 times 10 to the power 3 joules. Sorry, not newtons joules. Did I say newtons joules? I meant joules. What the hell is newtons joules? Okay. Oh, sorry. I rounded incorrectly. It shouldn't be 1.8. It should be 1.9. But, okay, besides the point. The pumpkin is pushed up at a constant velocity along a frictionless incline shown in the diagram. How much work is done on the pumpkin moving up the incline? So we know that it's pushed up at a constant velocity and it's frictionless. So there's something interesting about this box. So gravity is acting on multiple directions in this incline. Gravity is acting in this direction. In this direction, perpendicular to the surface. Gravity is acting in this direction, down the incline. And gravity is also acting in this direction. So this is considered the y component of gravity, FGY. This is FGX, and this is just FG. The frame of reference is in this direction, just to make it clear. And FG is calculated. Okay, so by the way, FGY and FGX are perpendicular to each other. They make this. And there's also an angle here. And this angle is equal to this angle because this angle plus this angle is equal to 90 degrees. And this angle plus this angle also has to equal 90 degrees. Therefore, this angle equals this angle. By the way, because this line is perpendicular to yes, because this line is perpendicular to the surface. It makes 90 degrees with the surface. So we just have to calculate this angle and we'll get this angle too, since we can calculate easily using sine -1, because 7 over 10, because opposite over hypotenuse. That's why we're using sines. That's the information we've been given. So that's sine inverse times 7 divided by 10 is 44.427. So 44.427 degrees. So the gravity moving in this direction is equal to, so like FGX is equal to the applied force, since it's at constant velocity. So let me just make the F net equation to prove that to you. Since F net x is equal to FA minus FGX, and we know that F net x is equal to 0 since it's moving at a constant velocity. So FA is equal to FGX. Now since we have that, what is FGX? So FGX is, we'll just use cosine laws for this one. So, sorry, sine law for this one. So we have this angle right here. We know that we know FG, which is mass times gravity. Now FGY, it's opposite to this angle, so we can use this. So FGX is equal to FG sine and sine theta, which is 44.427 degrees. Now that we have this information, we can calculate the work done. So we can calculate mass times gravity times sine 44.427 and times the incline, which is 10 meters, times the distance it travels, which is 10 meters, and I'll put this all in my calculator. 80 sine times Sorry, 8 times 9.8. So the answer is 5487.9996. Since there is 3 sig figs, we can get the answer to 5490. Okay, 3 sig figs. No, actually no, there's not 3 sig figs. Over here you see there's 2 sig figs 7.0. So the answer would be 5500 joules. That's the amount of work done. Okay, so I won't do 9 and 10 because they consist of friction, and I'll do friction with friction in the next video.